This is standard 8GA1. We're into geometry now. We're going to be talking about moving figures around, creating congruent figures, and even creating similar figures. Now, what this standard says is that we're going to verify experimentally the properties of rotations, reflections, and translations. Those are what we would call our congruence transformations: rotations, reflections, and translations. They create a figure that's the exact same size and shape as the original. Now, when we have congruence transformations, lines are taken to lines. That means if I start out with a line, it's not drawn very well, but if I start out with a line and I move it somewhere, I reflect it, I translate it. Let's say I were to translate it and move it down. I'm basically going to have the same line. If I start out with line segments, they're taking the line segments of the same length. If I have a line segment here, and it is 2 centimeters long, and I reflect it over, let's say, the y-axis, what I'm going to wind up with is a segment that is 2 centimeters long. They're going to be exactly the same length. The pre-image and the image. What you start with is called the pre-image. Pre-image. What we wind up with is called the image. And if this one was a B, those were the 2 points, this would be the pre-image points. After I have reflected it, the point I would get over here is called A prime. This point after I reflect it is called B prime. This would be my pre-image, this would be my image. And notice they're the exact same length. They are congruent because this is a congruence transformation. Rotations, reflections, and translations are congruence transformation. They create an image that's exactly like the one that you had before. It would be the same size and shape, but that's not the only thing we're talking about. What we're talking about is that we know that these side lengths are the same. What if we have an angle? What if I have an angle? What if I have a 30-degree angle? And what if I translate that 30-degree angle over here? That means I've just moved it over. I'm still going to have a 30-degree angle because I did not change the size or the shape of this angle. What if I start with parallel lines? If I start with parallel lines, I'm going to wind up with parallel lines. If I take a set of parallel lines and I decide to translate them up, I'm still going to have parallel lines. So let's look at this. Let's look at what we're talking about. We have congruence transformations. They're called translations, reflections, and rotations. And congruence transformations generate congruent figures. Congruent figures are figures that can be mapped right on top of each other, and they will be exactly alike. Let's start out with a translation. And what I have done is I have already created one that's just like this one. Look, I start with that figure, and I have created one that is exactly like it. I can map them on top of each other. A translation means I simply move it over or up or down or back. A translation is when I take an image and I move it. And I do it by points. I take each point and I move it. Notice how I've moved this one over here. Now, notice something. If I started out with this, the side lengths are going to be the same in the original image and in the final image, okay? If I take this image and move it over here, notice this side length is the same length as this one, right? That side's the same length as that one. I can put them on top of each other and check. The hypotenuse is the same length as this hypotenuse. So the line segments do not change length. How about the angles? Let's look at this and see. Look at this top angle here. What do I see about this one before I translate it? They have the same angle measured on it. If I translate it, that angle measure doesn't change. How about the right angle down here? If I start with the right angle and I translate this over, These two are still right angles. They still have the same measure, right? Okay. So when we've got a translation, I create two figures that are congruent. They're exactly alike. I can map one on top of the other to prove that they are indeed congruent. If I start back here, they're exactly the same, and I just move this one over. That means I've translated it. Let's look at a reflection. In a reflection, I also create an image that is congruent. Now we're going to do a reflection here. I've already created this image so we could move it. Notice these are exactly the same image. I can map them straight on top of each other. What if I wanted to reflect it over this line? And I'm going to move this line over here just because it'll make it easier for us to do it. But your line could have stayed where it was. What if I take this second one that we have here, and we want to reflect it over? The first thing I'd need to do is I am going to flip it over. Okay, so let's do that. Let's flip it over. I think we need to tell it to flip over this way. Let's see. I need to flip it. Okay, I'm going to flip it left to right. So let's flip it. Okay. All right. I flipped it over. Now let's take it and, oops. Now you can see what a reflection is. A reflection is when we just simply fold the paper. If you were to draw this image, fold the paper, and then draw it over here. You have created two images that are congruent. This line would be exactly the same length as this line. This point and this point are exactly the same distance from this line of reflection. Those two figures are congruent. Whenever you create a reflection, you create two figures that are congruent. Now let's talk about a rotation. First, let's look at this figure. When we talk about a rotation, we're rotating something around a point. In this case, we're rotating it around this 55 degrees right here. We're rotating it around this point right here, and we're going to do a 55-degree rotation. We want to rotate this 55 degrees. See, and it shows us we're going this direction with it, 55 degrees. Now notice, what if we take a line here and we draw us a line so we can see it? Okay, I'm going to draw a line. Now let's notice, what if I just take my line and I move it over here? What I have done is I have moved this point here to there. Notice the distance from this center of rotation is the same for both of these points. I've just rotated it 55 degrees. And you do the same thing with each point to draw your new figure. Pre-image, image. You've gone from a pre-image and you've rotated this pre-image 55 degrees. You've rotated each point in this pre-image 55 degrees to get a new image. This is the center of rotation. This is your angle of rotation. Whenever you're talking about a rotation, you have to have a center of rotation and an angle that you rotate it. So, what if we choose to rotate this figure here? Okay, first off, we're going to copy this one. Okay, let's copy this one. Let's say copy. Okay. Okay, so I've got a different one. I've got a new one. I'm going to put them on top of each other so you can see that these two are indeed the same size and shape, that they are congruent. If I can map them on top of each other, they're congruent. Now, let's take this one right here, and we're going to rotate it. Okay? We're going to rotate it around. Okay, let's see. I want to rotate it 90 degrees. I've rotated it 90 degrees, but whenever I rotate it around a point, if I rotated it around this point here, it's going to look like this. Notice, I've taken this point and I have rotated it 90 degrees. Let's see if I can draw this for you. I've taken this point here and I have rotated that 90 degrees, okay? If I were to look at lines that I had drawn, let's do them right here. Let's draw two lines. If I start with this line and go to the corner, and then draw another one, go from there up to here. Please notice what I have formed right here is a 90-degree angle. I have rotated this point 90 degrees. I've kept it the same distance from the center. I've done the same thing with these other 2 points. I've rotated this one 90 degrees, see here to there. That's where I put that point there. So a rotation creates line segments that are congruent. It creates figures that are congruent. Now, we're still talking about creating congruent figures. What if we have parallel lines? It says parallel lines are taken to parallel lines. What if I have two parallel lines, AC and BD, and let's say we reflect them over the y-axis. When you're doing a reflection, you have to tell us what you're reflecting over. If I were to take this paper and fold it right here along this axis, these lines here would fall right on top of these. Line segment BD is the same length as line segment B prime, D prime. They're congruent. Line segment AC is the same length as line segment A prime, C prime. They're congruent. These are our pre-images because they're the ones we start with. Notice they don't have the tick marks on them. They don't have the primes on them. These are our images. This is what I've got after I have after it has undergone the reflection. Remember, here's your fold line, the y-axis. Now notice, these lines were parallel before we got started, weren't they? Okay? What happens after you have reflected them? Well, if they were parallel before you reflected them, they're still going to be parallel to each other afterwards. This line is not parallel to this one, but the two lines that were initially parallel create two lines that are parallel. The pre-images are parallel, the images are parallel. Now, what about angles? Let's think about this. If I take a figure and I rotate it, again, this is another one of these where we're going to rotate. That one was reflection. Here's a rotation. If this is my pre-image, triangle ABC, and I rotate this pre-image by this angle theta, that looks like 90 degrees, doesn't it? If you rotate each line segment 90 degrees, then it's going to put it where it should be. In fact, let's draw some line segments in here just so you can see what happens whenever we rotate them. Okay. If I start out with AB, with A, this is where we are at our center. And if I rotate point A around here to A prime, let's see what our angle of rotation was. That looks like a 90-degree angle, doesn't it? Yeah, like a 90-degree angle right there. Okay. Let's try the point C. Let's see if we get the same situation there. Okay, let's go from point C to P. Okay, and then C to C prime. Yep, 90-degree angle there. See? Each one of these points, if you check them, you are rotating them 90 degrees. Same thing would be there with B and B prime. And let's look at this. What if we do that? Aren't our figures exactly alike? Wouldn't this one map onto that one? Wouldn't the measure of angle A be the same as angle A prime? Angle A then would be congruent to angle A prime. That means those two angles have the same measure. Angle B would be congruent to angle B prime. They have the same measure. How about C and C prime? Angle C would be congruent to angle C prime, because if I rotate them, I'm not changing the size or the shape. I'm not changing the angle measures. Now let's look at the side lengths. AB. What would I know about line segment AB? Wouldn't it be the same length as A prime, B prime? Line segment AB would be congruent to line segment A prime, B prime. How about BC and B prime, C prime? Line segment BC would be congruent to line segment B prime, C prime. And the same thing with AC and A prime, C prime. Line segment AC would be congruent to line segment A prime, C prime. Now we've just shown you that when we've got figures that undergo rotations, reflections, or translations, they're congruence transformations. So all the line segments between the pre-image and the image will be the same length. All the angle measures between the pre-image and image will be the same measure. And lines that start out as parallel after they've undergone the transformation, they will still be parallel. Now the last part of this, we're going to add standard 8GA3 to this. We're going to describe the effects of translations, reflections, and rotations on the coordinates of two-dimensional figures on a coordinate plane. What happens when we've got these on a coordinate plane when we translate, reflect, or rotate them? Let's look first at a translation. On this one, it says translate the triangle shown 2 units right and 3 units down. So we're going to translate this 2 units right and 3 units down. Let's get our original, and then it says what would be the new coordinates for each of the vertices. So let's get the coordinates now for the vertices. This point is at -2, 1. So we're going to start at -2, 1. And then it says go 2 units right and 3 units down. From here, 1, 2 right, 1, 2, 3 down. We are now at 0, -2. So this goes to 0, -2. Let's try this point here. It's at -4, 1. -4, 1. 2 units right, 1, 2, 3 units down, 1, 2, 3. Okay. That's where that would be. That's at -2, -2. All right, now this point here is at -4, 5. And I'm going 2 units right, 1, 2, and 3 units down, 1, 2, 3. Okay, this is what our new triangle would look like when we have translated it. Notice our side lengths are the same in the pre-image and the image. This is pre-image, that's image. Notice our angle measures are the same. The figures are the same. Okay, what have we gone to? -4, 5 has gone to -2, 2. Now let me show you something. It said in each case we were going 2 units right. That means on the x-axis we were going from xy to x plus 2, because going right's 2 units, and 3 units down. That's y minus 3. Let's see if this works. Let's take this point. Each x we add 2, 2. I've got -2 plus 2, 0. -4 plus 2 is -2. -4 plus 2 is -2. That works for the x. Let's look at the y. Y minus 3. 1 minus 3 would be -2. 1 minus 3 is -2. 5 minus 3 is 2. Okay, so that's what we've got for the translation. Let's look at the reflection. Reflect the triangle over the y-axis. Here's your y-axis. It's right here, so we're going to reflect it over it. What would be the new coordinates for each of the vertices? Let's start with each point. This is at 2, -2. Let's start with that one. We start at 2, -2. Let's see what we're going to. Now, when we do this, what we do is we count to the axis we're reflecting over. This point is 2 units on this side of it, so the new point will be 2 units on the other side. That's at -2, -2. Okay, let's try this point. This is at 2, -4. Now, we count to the axis we're reflecting over. Count to the mirrors. I say 1, 2, 1, 2. If it's 2 units on this side, it'd be 2 units on that side. So notice how we have taken this line here to over here. We've reflected it. If I were to fold that paper, that's where that line would be. Now let's get this point. It's at 5, -3. I forgot to get the point here. This was at what? -2, -4. Okay. 5, -3. Let's count to the thing. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. That's where that point would be. And our triangle would look like that. Okay, we've gone from 5, -3 to -5, -3. What have we actually done here? I just want to show you this. We started with an XY. And in each case, we changed the X, didn't we? We did the opposite of the X, and we didn't change the Y. I'm just showing you that. It's not something you need to memorize, but I'm just showing you that. That's called a rule. Now let's look at a rotation. Let's rotate the triangle ABC 90 degrees clockwise around the origin. Clockwise, guys, it's like a clock. It would go this way, 90 degrees. Remember, if we go a full circle, we have gone 360 degrees, okay? If you divide 360 by 4, that's 90 degrees. So we are talking about just going 1/4 of a circle, 1 quadrant. Now, so we want to rotate this clockwise about the origin 90 degrees. What we're going to do is, usually you would use paper to do this, tracing paper, but since we don't have tracing paper, what we're going to do right now is we are going to use our little line, and we're going around the origin. So let's take each point. Here we are. Now I need to go 90 degrees, okay? I need to move this point 90 degrees. I want that to be at a 90-degree angle. So I'm going to take this line and I'm going to move it 90 degrees. I'm going to copy this line. Okay, oops, that's all I needed. All right, let's get this line, which is what we want, and see if we can move this one. Now I'm trying to move this 90 degrees, so I want it right on top of it, but I want to move this part 90 degrees. All right, I don't want it to change size. Okay, and if I go 90 degrees, let's see, where is that going to put me? Right there. Okay, I've moved it 90 degrees. I've moved that point 90 degrees. It started out -2, 4. It's now at 4, 2. Okay, so let's put in our thing here. We started at, on this point, we started at, A was at, A is at -2, 4, and A prime, this is where we're moving it to, is going to be at 4, 2. Okay, let's look at B. B is currently at 3, 6. Okay, let's see where B goes to. Let's go up here and let's grab B. Let's draw us a line. And if we start from here with our line, we can draw a 90-degree angle here. And let's copy that line right there. put it right over here. I'll move our line so it is, oops, let's grab the line, move the line so it's here. We're going to move it down. This is at 2, 6. All we've got to do is we're going to grab one edge of it, and it's going to go to right there. That's our 90-degree angle. That puts us at 6, -2. So our B prime is going, I'm sorry, 6, -3. I put that the wrong spot, didn't I? Hold on, let's fix that. There we go. That's it. That's it. 6, -3. I know. Yep, 6, -3. Okay. And wouldn't that give us an idea where our third point would be? Let's look and see what we've done. We start with our xy and what's happening. Let's see. We went from -2, 4 to 4, -2. So we swapped those around. We went from xy to y, and it's opposite of x. So our C, which starts at 2, 1, would wind up being the opposite, let's see, which is 1, -2. C prime is at 1, -2. Let's get this back on our pen. Let's find 1, -2. C prime would be at 1, -2. So we could draw our triangle. It would look something like this. Oops, not very good at drawing, am I? Okay.